Hi, it's Kevin Lobates here, walking on very icy paths in Finland. And today's video is the continuation of the Ledgers 101 series, and it's video 2, so let's call it Ledgers 102. And I promised in the previous video that I was going to talk about some of the tricks and stunts that you can pull given the fact that tokens are instantiated on a ledger. And that's what I was talking about in the previous video. Oh, and the fact that there are these things called events that you get your contract to emit to indicate that something has happened to the state of the ledger. So to put it in a nutshell, tokens exist because balances of the token are listed in one data structure, and the world outside is informed that things have happened to those balances through the use of something called events. So they're like a second log as to what's actually been going on. And therefore the second things are not strictly necessary to create and allow the transaction of tokens. They're more a convenience thing to make it easy to search for the occurrence of events and transactions that affect that first data structure. And the other thing, I'm not sure if I mentioned it or not, so maybe I should go through it again. This is the question of balances, which is when you have a ledger that says here's a list of names and here are their balances, there is a traditional response if you ask for the balance of somebody who's not on the list, and that traditional response is to say their balance is 0. But that is actually structurally underneath different from looking up somebody, finding them on the list, and then looking at their balance entry and finding that it's 0. And an analogy for that is, to the best of my knowledge, Arnold Schwarzenegger, who lives in California, does not bank with the Finnish bank Nordea. And so if you go and ask the Finnish bank Nordea, what is the balance of Arnold Schwarzenegger? The answer they will give you, if they are going to ignore all the privacy laws that exist around traditional finance, the answer they're going to give you is his balance is 0. But the real answer is he doesn't actually have a bank account here. That's why his balance is 0. And that is very different to going to somebody who had a bank account at Nordea, but then withdrew all their money so that they had no balance. Because when you ask there, the answer, if you are being factually correct, is yes, they have a bank account here. And when we checked its balance, the balance was 0. Those are two different things. So this is where we can start playing a trick in the distributed ledger world, which is if you're writing a smart contract that creates such a 2-column ledger of addresses and their balances of the token that the smart contract creates, you can create something called a balance of function, which is a convenience function that allows people, well, it's not convenience actually, because without it you don't have an ability to look into the data structure. So it's an important function that allows people to query what the balances are of various addresses on the blockchain. And if you write the balance function in such a way that it intercepts the response and notes that a 0 has been returned for a balance, it can then say, right, well, if I get a balance of 0, I'm going to say that the balance is actually 100. If I get a balance of 3, I'll say it's 3. If I get a balance of 5, I'll say it's 5. But if I get a balance of 0, I'm going to say it's 100. And that will magically create 100 units of your token for every address on the blockchain. Because if you pick a random address that has never been used before, and you go and query that balance function for the balance of that address, it'll get back from the internals of the blockchain system that the balance of that address is 0 because it's not on the list. And then the balance of function will intercept that and say, when I get a balance of 0, I'm actually to return the answer, it's got a balance of 100. And that is, in summary, how my DETS ERC20 token drop managed to provide every single person or every single address on the Ethereum blockchain with 100 DETS tokens. It's kind of a way of rewriting reality mid-flow in order to get the result that you actually want. And I think it's kind of fun. And I've been investigating all sorts of knock-on possibilities that this could involve. One of them is a project I've been working on with Richard Piacentini, which is to use the same mechanism in order to provide every single address on the Ethereum blockchain, and as it happens now, the Polygon blockchain too, with their own NFT. And that uses a very similar approach. There are a few tricky things that have to be overcome because non-fungible tokens do function slightly differently to fungible tokens. But in essence, it's the same trick that we are using there for the NFTs. Then you might actually say to yourself, well, if it always returns a balance of 100, if the balance is 0, then we've got a bit of a problem on our hands, because if somebody spends all their airdropped tokens, their balance goes back to 0, and now we're in a situation where they'll suddenly have 100 again. Well, you might think that's a fun thing to do. You might actually decide, you know, what I want is that whenever anybody spends all their 100 DETS tokens, then they magically get another 100. That would be one choice to make. I actually made a different choice, which is I wanted there to be the possibility that people could have a balance of 0. And here we have a problem, because when you ask the Ethereum virtual machine what is the balance of this address, it returns 0 if they're not on the list. It also returns 0 if they are on the list and their balance is 0. And how are you going to keep track of which of the two cases is actually happening here? And the answer is that you can't tell in a smart contract whether the 0 being returned is because it's not on the list or because it actually is on the list with a balance of 0. So here's where I use the second trick. And again, it involves intercepting the balance of function and making it do something slightly different. What I decided was that if somebody is not on the list, it'll return that you have a balance of 100. The second thing is to make sure that if somebody is on the list, their balance can never actually be the number 0. And how am I going to explain this one simply? So what I do is, if you are on the list and you have a balance that isn't 0, it returns your balance minus 1. So if you're on the list and you have a balance of 1 DETS token, the balance of function will return the statement that you have a balance of 0 tokens. And similarly, if it goes and checks and finds that you're on the list and you have a balance of 101, then it will return the answer that you have a balance of 100. And this allows me to create a situation where I can have people who have a balance of 0, because I'm kind of using 1 token as an indicator that they have nothing. Now, this may sound counterintuitive, but again, it's an interpretation of the underlying reality of the blockchain. It's like deciding that you're going to start counting from the number 1 rather than from the number 0. And then you're going to say that the value that you're counting on is actually 1 less than the point that you really are at. So where you start counting on the number line, in a sense, is arbitrary. Traditionally we start counting at 1. In fact, mathematicians have argued in the past whether you should start counting at 0, whether 0 is a natural number, which is the mathematical term for counting numbers, or whether it is not. And some say we should start counting at 1, and others say we should start counting at 0. Well, what I'm doing in my contract is I've decided that I'm going to start counting at 1, but I'm going to report 1 as 0. Make any sense? Maybe it's got a bit complicated there. But those of you who do a bit of programming and go and look at the smart contract code will notice that when I report the balance, it subtracts 1 from it precisely for this reason. And you can find a few other tricks in the contract as well. So I'll put a link to it on Etherscan in the comments below. Anyway, that's video 2 on ledgers. Got a little bit more technical there. Some of you may want to revisit it in order to really understand what's going on, because I don't think I explained it brilliantly, but I think it's comprehensible or comprehensible. Some of you may just think, oh, well, he's got too technical for me, I'm going to ignore it. And that's fine too. We don't have to understand everything that goes on in the world. This is more just if you're interested in it. Anyway, in the next video, the final video in this series, I'll be talking about the Bitcoin ledger, because Bitcoin uses a different mechanism for keeping track of balances. It doesn't use a 2-column list with addresses and balances. And that gives us different opportunities to do fun and subversive things with the underlying mechanism. But that's it for today. Hope you found it interesting, and I'll see you in the next video soon. Bye for now.